Now, I've already covered the term AI factory ad nauseum. And that is more design pattern than metaphor, in my opinion. But we could also talk about it another way, scaling. It's token production, right? So we just talked about token production. GB10, Spark can do token production. Supermicro is showing off OpenClaw running on DGX Station. We're doing an in-depth look at that. But not just DGX Station, but also for the same money, you could get a server chassis that has 8 RTX Pro 6000s, 8 times 96 gigs of memory. Now, it's not as fast as HBM3, which is not great for certain kinds of tasks, but if you're running inferencing or video search and summarization or anything like that, yeah, no, it's totally fine. But the scalability here, I think, is really interesting. You go from desk side to cloud, and you're really able to accomplish a lot. Spark, a 3-way Spark cluster that we saw on the floor, that was not officially supported or sanctioned by Nvidia. But one crazy dude on Reddit was able to put together a fully meshed interconnection version that is NCCL. And so that could be adopted into NCCL, and that literally will scale to things that are not a Spark cluster. You could do a 3-way DGX station with ConnectX-8, the ConnectX-8 NIC in there, and have direct connections to all 3 DGX station nodes, and that's scalability. It's GTC 2026, in full disclosure. Supermicro has sponsored my travel out here, and Nvidia has seen to my attendance. So I got an attendance badge from Nvidia, and Supermicro's paying for me to be here. So fun times. But just to be clear, my opinions are mine. So this is Deskside AI, like literally Deskside AI. What are the speeds and feeds on this machine?
Well, it all starts with the Nvidia GB300 Blackwell Ultra desktop super chip. So it has a Grace 72-core CPU with a B300, a Blackwell Ultra GPU, which has 252 gigabytes of HBM3E memory and 496 gigabytes of system memory, all coherent. So the system's able to process it as 748 gigabytes of coherent memory.
Sometimes the upgrade is not really tokens per second, it's the number of experiments that you can do per day. And sometimes that means local. When you're talking about scaling AI, scaling it from the desktop to the cloud, it's like we have Spark, and Spark is 128 gigs, and like that's okay. But this is even more toward something that would be like what you would encounter in a data center with a large scale deployment.
You know, you're absolutely right. This, like I said, this is the GB300. So this is the exact same architecture that powers AI factories around the world. So when your developers get access to a system like this, you can rest assured that your code that's running on this powerful machine is able to scale to your production environments with the same architecture.
So what do we got running here on the machine behind us?
So right now we have OpenClaw running. So I have Ollama as the local inference engine, and I have OpenClaw running in a Docker container over here just to keep the environment a little isolated. And we're just showing off some of the capabilities of this. So right now it's being powered by the GLM 4.7 flash model. However, as you can see, this machine has so much memory, it can really be powered by Qwen 3 235 billion or even much bigger models of that. And yeah.
So you're running the Nemotron services through Docker, and then you're also running Ollama, and then Ollama is hosting the GLM 4.7?
That's correct. That is correct.
And so all of that is running locally, and it runs fine. It's like, oh, I need help building a new program. It's like, okay, we can do that.
Absolutely.
The memory system and interconnect story here is a big part of why this is interesting. Local is not the same thing as small. Remember that. With DGX Station, local is not the same thing as a small model, or even, one of the RTX servers. What is the most interesting use that you've seen? The Ricci robot from over there? It's like,
yeah, that's an interesting one because, they didn't originally develop on Spark, but we have it running on Spark. But they took OpenClaw, took the Ricci robot and said, build me an assistant. I wanted to be a friend to the family, recognize the family, talk with him, but also help me review my code, help me manage my calendar so he can actually talk through changes they might want to make in his code and what's going on, discuss his calendar. So it's really interesting that they turned it into kind of a personal assistant, but also a coworker, and gave a robot, so it's got almost a human face to it.
So in that role, Spark is it's potentially running the AI, but it's also potentially running the tool chain that's doing everything and controlling the robot.
Right, it's got the toolkit for the robot is on the Spark as well, so it's running that.
If this were a restaurant, DGX Spark shows me the menu for the restaurant. DGX Station gives me the kitchen. Spark is the playbook layer. DGX Station is the local factory floor. Nice. And with Nemotron, the 120 billion parameter version of Nemotron 3 Super, I think is.
Yeah.
And so that all runs locally, so that's an option. You can also run AI in the cloud or connect to services.
Yeah. It gives you a pretty nice brain to have. I think that's one of the big challenges with the claws is you want to have a good brain to run it, and running local is kind of a challenge, but when you have a lot of memory and a pretty good powerful GPU in there, it allows you to run things like Nemotron and have a good brain locally. So, and that helps people with security concerns, right? I can run more things local and not have my data going off to the cloud or somewhere else.
Yeah, or just, it's an experimental sandbox because there is some paranoia around, I gave it an API and now I've got an $87,000 bill. You're not going to have that problem if you run everything on Spark.
If your tokens are generated here, your per token cost is just what you paid for it, nothing extra. And so that's
So it's been a little while since Spark launched. And I'm sure you've been tracking like the utility of models for Spark. Like what's something you've noticed, or from my perspective, it seems like the utility of models from launch to now has gone up just pure hockey stick.
Yeah, it's really models. If you look at what they're doing, they're always going in both directions, right? We want smaller ones to run on our phones and edge devices, but they keep pushing these trillion parameter models. So the big models are out there. The goal, what I see, is that sweet spot in the middle where the intelligence is getting better.
Intelligence per token.
Right. Even writing code 3 or 4 months ago was a little sketchy. It's pretty good now. And there's models like Qwen for code writing that are pretty good that you can run local. So I think there's such a greater variety of models, especially now with our Nvidia FP4, where we can give you the accuracy of an FP8, FP16 model at 4 bits. It really helps to run things locally, and we see a lot of people adopting more and more of those models to run local.
AI scaling down like this means that more teams are able to run more workflows like this locally and do experiments and find productivity. It's not being forced upon them, but when you have a team that embraces this kind of tooling, it really can tremendously multiply their productivity. That's what everybody's discovering. Yeah, and the story, I think, is really interesting, from 2 DGX Sparks to 3 DGX Sparks to fully connected mesh, and then 4. The 3 DGX Spark thing, I saw that it was completely unhinged. There was a guy that was like, I want to run 3 Sparks in a cluster, but NCCL doesn't support that, and like tensor parallelism, like 3 is a little sketchy. I mean, it works well for multi-agent, but like one giant model, maybe not. And then he's like, I'm going to vibe code this. And it was a little more involved than that, but then boom, 3 Sparks. And I've been running 4 Sparks on a MikroTik CRS 812, and that's worked really well.
Yeah, we're working it, so we're always improving. The thing to remember is that if you want full performance, it's 200 gigabits aggregate for the 2 QSFP ports. So in this case, that we've got them kind of in a triangle in a cluster there, you're only getting 100 gigabit per port. So if you really want, even for 3, to maximize your performance, you're going to want to run it through a switch. But you can do it this way, and we're always looking to improve. And if people have bugs or issues, let us know on the forums.
What's this 4 setup with?
So this is really just kind of a concept for the show, so a stack of them. But normally you would just have 4, and you might stack them like that on your desk and plug them into the switch. But this is just something nice for the show. We wanted to have a nice concept display.
And one of the ideas with this is, like, as we think about AI, as it scales up to the cloud and everything else, this provides a software vehicle and like a familiarization vehicle, I guess is.
Right, and it's a way for you to scale and test and see how things work scaling, right? It's one of those things with a Spark on your desk. If you don't have access to a cluster that you can test with in a data center, which most people probably don't have that luxury, you can build your own little cluster. Test it out there, and if you want to deploy, at least you've had that experience. You know how the model and the tools scale across nodes, and helps you to go. And of course, NVIDIA's tools run everywhere, so we can give you the foundation to be able to migrate.
It's still a little hard to get hourly time on a B200.
It is. It's not easy, and I work in NVIDIA, and I can't get time there. So if you're lucky enough to have one, I'm very happy for it.
So I'm curious about how that requirement came across your desk. It's like, we're going to do this. We're going to build something where you can have the giant multi-million-dollar AI experience in a little box on your desk from a software developer standpoint. Or did that just kind of come together as part of the ecosystem planning? Or handling the logistics of that seems like that would be really challenging.
Well, NVIDIA's, since the CUDA launch, right, the whole idea of CUDA, it's a compute unified architecture, right? And so the goal from that very beginning was that everything runs everywhere, right? From the smallest little Jetson to the biggest data center, it all runs. And so Spark is just really a continuation of that, right? It runs here, it should run in a data center, it should run on a Jetson. Now, the variable is performance, right? Obviously, can get much more performance out of a big data center rack than I'm going to get here, but the beauty is developers can work here. And as we mentioned, save that precious data center resource for and ready for your final testing and deployment. So that's the beauty of the Nvidia architecture. It's all unified from a hardware and software standpoint, and you can run anywhere.
This is why I think some people have described this as, an industrial revolution. How the labor is being accomplished is changing. High agency individuals can accomplish more with this tooling than they can with, a larger team. And a larger team is able to accomplish Herculean feats in much shorter order. One of the favorite things that I like to do that doesn't require a lot of typing to get the prompt going is to ask the model to write an efficient Python program to search for perfect numbers. The difference here is that we will be able to generate a Python program directly as opposed to having to copy paste. The agent has access to do that. It's also a fun and deceptively your .env is showing. That's funny. I'll pretend I didn't see it. The agent is kicking off, the GPU is getting busy, but perfect numbers are really interesting because you really ideally would use like Mercenine primes, and there's all kinds of stuff you can do to efficiently, like you can brute force search for perfect numbers in like 4 lines of Python. But it is also deceptive because if you know a lot about perfect numbers, you end up writing absurdly complicated programs to search for perfect numbers efficiently. I want to take a second and really deep dive into what we just saw with the DGX station in the Supermicro booth, because it's really interesting. It's running a local model. Yeah, big deal. That's the most pedestrian thing here. But there is a lot of other background tasks running, and it's all running via Docker orchestration. And we're running NemoClaw in the background. And NemoClaw gives those models access to the local file system and everything else. But it's still able to do safe operations. Like Nvidia has added some safeties to NemoClaw, the same way that, personal, level 1 projects, things like Turnstone. It's like, oh, we need to add safety. We need to add enterprise capabilities to that. It needs to be a little bit safer. Same kind of thing. It can manipulate the Python files directly. We can see that in Visual Studio Code, and the model is still smart enough to understand about the tasks that I gave it, which is perfect numbers and perfect number efficiency. It commented the code. It added documentation, README. It did lots of nice things to make it more human accessible. If I were to ask it to, modularize that, or we were to expand that into a more complicated project, it would be able to do that. And then the review step for me is a little easier. But the agentic part of it is there are other AIs running, watching what the first one is doing. That's a little bit more on the Turnstone side of things, the other project that we have, but that is also a capability in NemoClaw or OpenClaw. So you could have an agent running saying, evaluating the code, is this well documented? Is there anything else that we can see here? You can also mix models. You can have a smaller model that's doing the supervision, or you can have a model that's specifically built for certain kinds of things. You can do video search and summarization models for video search and summarization if the task that you're doing requires that, but then another model that's analyzing the output of it. And this scales from DGX Spark, the DGX Station, to the larger systems, B300 systems that we see in the Supermicro booth. So you could just get a single B300 system all the way up to the NVL72 racks. That's really good software scalability. It's basically the same Docker Compose and the same Docker projects and the same end user experience anywhere in that scale. So it's like, oh, I need to scale this from my desktop to 1,000 users in the organization. The software part of it is really not a heavy lift once you've got it running. Okay, as we talk about scalability and scaling and token generation, we've got DGX Station, but I was just doing a little bit of cost analysis here, and RTX 6000, I can get 8 of those for the same money in a chassis. Maybe that makes sense. These are the PCIe options.
Yeah.
The 3 that we have here is just Blackwell in a different configuration, a different chassis, and you can still do Bluefield.
Yeah, I think this is the reason why we're demonstrating so many PCIe GPU systems now. It definitely represents a shift in terms of infrastructure needs to support production AI inference, and in particular agentic AI applications. I do believe that the RTX Pro 6000 Blackwell Server Edition is also one thing that's driving this, with enough memory capacity to have comfortably sufficient AI models in a single GPU.
Now, the networking configuration here is a little different. We've got the option of Bluefield. This is like your more traditional server, but with a Bluefield, DPU, separate NIC. And then over here, I'm noticing we've got, eight QSFP ports here. It's a little different.
So this is the ConnectX 8 used as a PCIe switch.
So this carrier board has your PCIe slots. This is Gen 6. And then you've got a Gen 5 bridge back to the CPU.
Exactly. So it's a way to bypass the limitations of PCIe 5.0 and deliver 800 gigabits per second networking speed.
Now, this is a little more expensive than that, but it's still PCIe. I'm still rocking the RTX Pro 6000.
Yeah, exactly. So I think that's more like balancing the scalability and coherent memory with cost-effective PCIe-based GPUs.
And then this,
our classic PCIe GPU system.
It's like we've added a U, but we've redistributed the PCIe lanes.
Yeah.
So the PCIe lanes here, that's a lot of lanes. It's eating into our lane budget for the GPUs, but the GPUs have their own.
There's a variety of configurations that have a PCIe switch or not, or directly attached to the CPU root complex. But yeah, this is like our traditional system architecture in that it's very super micro designed from the ground up. So it's really like designed with that lot of very, very easy to maintain with like everything hot swappable.
And this is Intel Xeon based, Xeon 6,
yes,
6900B.
That, and we also have EPYC 9004, 9005 based variants of that system as well.
Nice, nice. What do we got going on over here? This is the HGX Rubin system.
So this is the HGX Rubin NVL8 system.
Jensen's been here.
Yep. So we got it done by the main man himself, Jensen Huang.
And this is an EPYC platform.
So this one is going to support a variety of different CPU options, including the Nvidia Vera CPUs as well.
For those of you not in the know,
X86.
Intel Xeon was what Nvidia has picked for like their, what was it, the STX and the LPX? I think the LPX host.
Oh, okay.
So yeah. But this is AMD EPYC.
Yeah, and in the future, other CPU as well. But you can see here that we've gone down to 2U form factor.
So this is NVL8. So 8
NVL8.
GPUs in here.
That's correct. So unlike
in 2U.
In 2U, 8 GPUs, 8 Rubin GPUs with 288 gigabytes of HBM4 memory. So each. So it packs a lot of performance in a very small, compact form factor.
DC bus bar, 24 kilowatts.
Yeah, so
that's a lot of kilowatts.
Do the math, and then but that's why in order to cool that's why direct liquid cooling is needed. And
24 kilowatts, and so this is also part of the story about scaling because you are right. You could buy something like this if you're not ready for an NVL72 deployment. This is NVL8.
Yeah. And for a lot of people, like 8 GPU NVLink domains, like going to give a similar, it's going to give them enough performance compared to this 72 GPU NVLink domain. So they might select.
8 GPUs with 288 gigs of memory has a lot of capacity to get the job done. So that makes sense. And there's lots of memory, lots of room for memory and CPUs here. So you can fine tune your application. If you don't need a lot of compute horsepower, okay. If you need more compute horsepower, okay. If you're leaning into Agentic AI, this gives you a platform where you can tweak and tune the CPU memory and the CPU side of it and be able to run x86 workloads for that Agentic AI without it leaving the cluster. The agents are local to where the GPUs are, although only NVL8 at a time.
Right. I think that it does give you a lot of flexibility in development. HGX has traditionally been like a sweet spot for customers adopting AI hardware because it has a good balance of capacity. But it's not as not like the highest tier of performance like NVL72 based solutions. But you can still scale with the networking, the 800G networking, integrated ConnectX 8s.
AI Factory is a design pattern, and scaling that down to the desktop is what this looks like. You can run it on something as small as a desktop computer with a gaming graphics card. But really what it does is it forces you into a workflow. You have to think about what people actually need. And as somebody who's worked on enterprise projects before, getting the executives to define what they need is often an impossible task. But in our AI future, you literally have to define that. What is the outcome? What does a successful outcome look like when you're working on this kind of a project? Have you thought about what your need is, what you're working on, privacy, sovereignty, iteration speed? What does it need to look like when you're working with a local model first? And then you can scale that local model as far as you need to, as far as your pocketbook will take you, as far as your business needs really require. I'm Wendell, this is level 1. I'm from GTC 2026. Behind me, like, there's people taking Nvidia exams and learning how to set up Run AI. I've been working for months trying to figure out how to set up Run AI, and they had a panel here to do that, and I missed it. So I'm going to keep working on my how to set up Run AI tutorial, or maybe I can get access to a recording. I don't know. I'm Wendell, this is level 1. You can find me in the level 1 forum. Hopefully still putting together that Run AI tutorial. All right, I'm signing out, and I'll see you there.